In the thumbnail to this video, we ask whether or not you can solve this differential equation here in 15 seconds. And you can, using this quite amazing trick, which I'll explain now. Now, let's just have a quick look at this. It's a first order non-homogeneous differential equation. At first glance, it looks very difficult because we can't separate the variables. And there's no obvious or even not so obvious substitution that we can use, so it's very difficult to know how to proceed. Okay, so what I'm going to do is I'm going to answer this question in the 15 seconds. Then I will explain how you can look for the type of differential equations which use this trick, and finally we'll do another one which is again very familiar, just to give a bit more practice on it. Okay, so let's just answer this. So let's just go dy times sine 2y minus x equals cos x add y dx. Okay, and let's expand all this out. That's sine 2y dy minus x dy equals cos x dx add y dx. Okay, and here is the trick. What I'm going to do is I'm going to take this and I'm going to move it over here so that we're going to get sine 2y dy equals cos x dx add y dx add x dy. Okay, and then I'm going to integrate the whole lot, and let's just have a look at this bit here. Well, the integral of y dx add x dy is equal to xy, and that basically is why this trick works. And just to sort of prove that, let's just if we differentiate xy with respect to x, and forgive the somewhat informal nature of this proof, but if we differentiate that using the product rule, we get 1 times y add x times dy dx, and then if we multiply, I know you can't, but if you multiply, then you basically get dxy equals dx times y add x times dy, which basically proves that the integral of that equals that. So basically now all we got to do is we've turned this rather horrendous thing into an extremely simple integral. The integral of sine 2y dy is minus cos 2y over 2, and that equals, the integral of cos is simply sine x, and then add down here xy, add our constant of integration. So basically sine x add xy add cos 2y over 2 equals k, whatever k is. And that is the general solution to this differential equation, and it definitely can be done in 15 seconds if I don't talk non-stop. Okay, so that's the answer to the question. What type of differential equations can we use this trick on? Because it's very powerful. Okay, so let's have a look. Well, these are basically the 3 forms where you can be looking, and the trick is that we need, if it's in this form here, dy dx equals f of x, and f of x can be anything, and g of y can be anything. If it's plus y, then it has to be minus x, and if it's minus y, it has to be plus x. And when we expand all of that out, we will end up with x dy add y dx, which we know that we can integrate as xy. The other form of that, I mean, all 3 of these are exactly the same, but basically if it's in this form, then we need f of x can be anything plus y or minus y dx, and the x needs to be either plus or minus again, so that we end up being able to get that. And if it's in the 3rd form here, which again is just basically that form, just converted slightly, but different people seem to prefer different forms, the plus y and the x must be the opposite sign. As long as this is the case, you can use this trick, and it's very powerful. So let's just have a look at one more example here. And this one, I actually got this off a college entrance exam. Again, you can't separate the variables. It looks on the face of it as if we have no idea how to proceed in terms of substitutions or whatever. But if we just look at this and this, we have fx, it doesn't matter what it is, and that's minus y dx. And then we look here, and this here is g of y, so we have g of y add x dy. Then basically we have our minus y dx and we have our plus x dy, which means that we have it in the correct form, and so therefore we can do our trick. So let's just go down here, expand it out, x dx minus y dx minus 3x squared dx equals x dy minus y dy, and then we just do our little trick move this over here, and then we get x minus 3x squared dx equals, where are we, x dy add y dx minus y dy, and then we integrate. This is simple. That will just be x squared over 2 minus 3x cubed over 3 equals this. Well, we've already discussed this. This is xy, and that is simply minus y squared over 2 add c, so i.e. x squared minus, well, that's x squared minus 2x cubed equals 2xy minus y squared add whatever, some constant d. That is the general solution, and then we go on to do whatever the rest of the question says. It's very, very powerful. Just make sure that you look out for any of the differential equations in any of these three forms. Remember, f of x and g and y can be literally anything. And then hopefully this trick will help you. If you've enjoyed this, please like this video and subscribe to the Gressy Academy YouTube channel. Thank you.